Four concentrated charges are located at the vertices of a plane rectangle shown in figure. Find the magnitude and direction of resultant force on Q1. All charges are in microcoulomb. We have four charges situated in the four corners of a rectangle. We have to find the force on charge Q1 due to these other three charges. So we know how we can find the force on this Q1. So that can be represented as F1. Force on Q1 can be represented as F1. This total force on this Q1 will be equal to force due to this Q3 charge and force due to plus force due to Q4 charge and plus force due to this Q2 charge. So we can represent force on this Q1 is F1, which is equal to, due to this charge Q3, force on Q1 will be represented as F of 31 plus force on Q1 due to this Q2 charge is represented as F of 21 plus force on Q1 due to this Q4 charge is represented as F of 41. Okay, and we had to find, in this question we had to find the magnitude of this force and this direction of this force, which direction this force is acting due to these three charges. So first we can find all these magnitude, all these each forces magnitude we can find. So we know the equation according to Coulomb's law. We defined how we can find force on charge Q1 due to this charge Q3. But we already find out according to Coulomb's law, that is 1 by 4 pi epsilon 0 Q1 this Q3 divided by this distance between these two charges square. So we can represent 1 by 4 pi epsilon 0. That is 1 by 4 pi epsilon 0 Q1. Charge Q1 is, we know that is 0.2 microcoulombs. So that is 0.2 into microcoulombs. Then Q3 is minus 0.2. So again minus 0.2. Then microcoulombs are both charges. So this becomes 0.2 into 10 to the power minus 6. Here it is minus 0.2 10 to the power minus 6. So both becomes 10 to the power minus 12 divided by distance between these two charges is 2 centimeters given in the question. So we can written as in meter square, that is 2 into 10 to the power minus 4 10 to the power minus 2 the whole square. So this becomes, we can substitute the value of 1 by 4 by epsilon 0, that is 9 into 10 to the power 9. This becomes into 0.2 into 0.2 into 10 to the power minus 12. This is minus divided by 4 into 10 to the power minus 4. So the answer of this force of F of 31 becomes minus 0.09 Newton. Okay. Similarly, we can find the other forces. This F of 21. F of 21 we can find. F of 21 will be equal to 9 into 10 to the power 9. That into Q1 is again 0.2 microcoulombs. Then Q2 is 0.1 microcoulombs. This becomes, you can represent as minus 12 the whole divided by distance between these two charges 5 centimeter. So that becomes 5 into 10 to the power minus 2 the whole square. So this becomes 0.07 2 Newton. Again F of 3 for 41, this last force F of 41 becomes 9 into 10 to the power 9, that into Q1 is 0.2, then Q4 is 0.1 into 10 to the power minus 12 divided by distance between these two charges. So this is 5 centimeter, we know that, and this is 2 centimeter. So this 5 centimeter and this is also 2 centimeter. Then what is this distance then? This is the diagonal distance, that is 5 square plus 2 square. So this becomes root of 29. Root of 29 into 10 to the power minus 2 the whole square. Okay. Then this becomes 0.062 Newton. Okay. So we found out the three forces acting on this charge Q1. Now we can find the direction on which the forces are acting. Here first we can find F31, the direction of the force on Q1 due to the charge Q3. Because this Q3 is a negative charge, so the direction of force will be acting in the downward direction. So this force will be attractive force, so that will be acting in the towards the negative charge, so it will be in the downward direction, that is this is F31. Now what is due to this Q2, force on Q1 will be both are positive charges, so this will be repulsive force, so it will be acting in this direction. So repulsive force, this F21 will be in this direction, negative x direction. And what is about this Q1 and Q4, the force between F41 will be, that is also repulsive force because these two charges are positive. So and this direction of this force will be along this direction, that is repulsive direction, is F41. Now we have to find the total force on this Q1, that is resultant of all these three forces. So f of 31 will be in this direction. So the value of f of 31 will be that we already found out, that is minus 0.09 Newton. Then f of 21 is acting in the negative x direction, that is repulsive force. So f of 21 will be minus 0.072 Newton. Then what about the case of this f of 41? So this will be acting in this direction. So we can take the two components of this f of 41. One is in this direction and one is in the perpendicular direction. And this f of 41 in this direction is f of 41. This angle we can take it as alpha. This f of 41 cos alpha. And there is another component of this force that is in this direction. That is f of 41 sin alpha. And this alpha and this angle alpha is both are same. Okay. Now, so the f of 41, this force is divided into two components, f of 41 cos alpha in this direction and f of 41 sin alpha in the perpendicular direction. If you take this angle as alpha, okay, this angle and this angle both are the same. Now, so resultant of all these forces, that is f of 21 and plus f of 41 cos alpha in the negative x direction, and the y direction there are two forces, that is only the one in the downward direction f of 31 and one in the upward direction f of 41 sin alpha. Okay, now how we can find this f of 41 cos alpha and f of 41 sin alpha? We can find this cos alpha from this right angle triangle, because this is also 2 centimeter. So cos alpha becomes, adjacent side is 5 divided by hypotenuse root of 29. So cos alpha is 5 by root of 29. Then what about sin alpha? Sin alpha becomes, opposite side is 2. 2 divided by root of hypotenuse root of 29. Okay, but we are not taking the meter, because 5 into 10 to the minus 2. If you convert it into meter also, here also root of 29 10 to the minus 2. Numerator and denominator both will cancel. So we are taking 5 by root of 29, and here also 2 by root of 29. Okay. So this next we have to find f of 41 cos alpha. F of 41 cos alpha becomes, f of 41 is that is in this direction, so that becomes minus 0.062 f of 41 into cos alpha is 5 by root 29. Now f of 41 sin alpha, f of 41 sin alpha becomes 0.062, that is in the upward direction, positive y direction, so it is positive 0.062 into sin alpha is 2 by root of 29. So the x direction force is f of 21 and f of 41 cos alpha. So we can write f of x, we can represent as f of x in x direction, that is f of 21 and plus f of 41 cos alpha is there. We know the magnitude of f of 21, that is minus 0.072 because it is in the negative direction, and f of 41 cos alpha is also minus 0.0575 Newton. So this value becomes minus 0.13 Newton. Now again, what is f of y? That is in the y direction total force. That is, this force is f of 31 downward direction. Then this will be in the upward direction, f of 41 sine alpha. This becomes f of 31 is, we know that is minus 0.9. Then plus, this is in the positive direction, so that is a plus 0.23. So this becomes minus 0.877 Newton. Okay. Now we can find the resultant of these two forces, one in the x direction and one is in the y direction. The resultant of these two x and y direction forces, so resultant will become in this direction F1. So this F1 can be represented as F1 is equal to this x direction force is minus 0.13 I, y direction force is minus 0.877 J. Okay, this is the resultant force F1 that should be in this direction because of resultant of these two forces. This will be in this direction F1. Now we can find the magnitude of F1. Resultant of F1 can be found by square root of minus 0.13 square plus minus 0.877 the whole square. So this becomes 0.887. This is become 0.887 Newton.